Hello everyone, welcome to our today's session. Today I'm going to explore a strong, intuitive, and powerful algorithm in data science, that is decision tree. And in this session, I'll guide you to understand the theoretical part of the decision tree. Okay, how decision tree algorithm works, and then in the next session, I'll show you the demo. I mean, create a dictionary model and test it. So today's session only theoretical part. Let's have a look. So what is decision tree? Decision tree actually you can see is a supervised learning algorithm. Is predict by asking a sequence of questions, simple question, yes or no type question, and it's continue it until it get a final prediction. You can think like is a flowchart analogy. Think of it as a logical flowchart navigate through data. At the right hand side, you can see this is tree-like structure, right? So here actually, does the person like computers games? Then this is for this problem. Actually, this decision tree asking some questions every step and try to find out the final prediction. So first it asks whether the age of the person below 15 years or not. So then it splits the data set into two parts. First is EPS, then data sets goes to the right and remaining the left side. Left side again is after person like is male, then EPS, then again splitting the data set in two parts like this way. Okay, actually I have included data set like where the mixed data set like different age group, different genders, okay, and occupations data present, and recently I had to split it and group those data and try to find out the final prediction. So that means for every question asked, the data is split into smaller, more specific group, right? And final prediction is like this process continues until a final prediction or categorization is reached. And this process actually here you can see only two steps I have shown, and this step you can may increase. It is depend on the how you set what number you have set in the model creation. I mean, actually, when we create the model, recently model, we actually usually pass the depth of the recent tree. I mean, how many node was it bottom it will go, it will traverse. Okay, so uh, for real life example, I just try to explain it by giving the real life example. It is loan approval. Imagine a bank evaluating a loan applicant. Okay, a bank manager may ask several questions to make a decision, like whether the credit score is above the some certain level. Okay, you can see the right side. There's a image and tree like structure. Whether is credit score greater than 700? If no, then loan approval will be rejected. If yes, then again ask another question. Okay, so income above 50K. Okay, if yes, then will approve. Otherwise, reject. So like this way, uh, uh, bank manager decide whether he will approve the loan or not. The same way our decision tree works to get to predict the final outcome. Okay. Now let's explain the nodal leaf of this tree. What is node? So first thing, why it is called decision tree? Because it maps out like an upside down tree structure, right? Upside down tree structure. And there is a root node is present. The top node is a true root node. So first question at the top, right? Then internal node is or branch. The immediate question that further split into the dataset on features. Based on features, again I split the dataset. Actually, each branch is the decision, and leaf node is the actually the output prediction from the of the above decision. So for this credit score, there is a two decision yes, and these two are yes and no. These are the two decision, and these leaves are sorry. Um, you can say the leaves are the leaf node are the prediction output prediction. Actually, in every level, we splitting the data set, as I said before. So, where decision tree used? So, a common misconception is decision tree are only for classification. Actually, no. They are highly versatile and belong to a family of algorithm. Okay. Actually, we can use decision tree in both classification and regression. Classification like the bank will approve the loan or not. Okay. So email is spam or not, uh, whether this prediction like the positive or negative, customer return or not, like this. And regression level is a continuous numeric value. Where the target is a continuous numeric value, this is the regression level. Like our previous session, I have already shown you the what is regression models. Okay, so house price prediction, salary prediction, sales forecasting. These are the example of regression. So we can use the decision tree in both classification and regression, but that slightly different present in the algorithm. For regression, there is a separate algorithm of the decision tree like uh, decision tree regressor model. Okay, so this is the for example. This is our customer data set. I mean loan default. You can see for customer income is 50K, credit score is this one, loan amount is, and default target is no. Yes, no, yes. I mean default, loan default, not default, yes, yes. Okay. So these are example data sets. Now let me explain how does it works. So as I said before, start initially uh, start with the entire data set. Okay, this example here only I have taken 4 rows. So first recently start with the all data set, all the customer are group on this. You can see there is a one group. Okay, no separate group, only one group. In one group, all the data set is present. You can say the no group is actually made at the beginning. Now our decision tree algorithm find the best question. The algorithm tries many questions like income above 50K or credit score above something. Okay, it chooses the question that best separates the target value, target classes like yes versus no. I'll explain some algorithm used by the decently to find the best question. I'll explain it later. Let me let me find out. Yeah, sorry. Uh, I will not write down over there. I will in the next session. I will explain how recently find the best question. Okay. For now, just know that use some internal logic or algorithm to find the best question. So, for example, the algorithm tries suppose the is choose the best question is like credit score. Credit score is greater than 700. Then dataset is divided into subset like yes and no. I mean good risk and high risk. So first in after this first question, data split into two parts. And now again, algorithm asks another question for each band. In income is above 50K or not? At the right side you can see. So again, it split data into two sets. So eventually, every leaf contains almost identical data. Then the algorithm stops the trained model is uh, stops and the trained model is complete. Okay. Now coming to the how it choose the best question, as I said above. But here I just simply I'll explain uh, in some briefly. In later on, I'll explain in detail. So this is the most important concept. The algorithm tries every possible speed and choose the one that creates the purest group. So goal put similar record together and stick separate different records and strictly separate different records. This is our goal. So actually there are two methods available for decently to choose the right question. One is Gini impurity and this is entropy. Most of the cases we use the Gini impurity. It measures the impurity. A group with 50 yes or no. Okay, a group with 50 yes or 50 no has a high Gini. I mean, it is like confusing. Suppose it a group of data where 50 customers is yes with target yes and 50 customers uh, with no. So equal number. It's a high Gini. And again, a group with 100 yes but 0 no has Gini. As 0 no, and it has Gini equals 0, but that is pure. As I said, the goal of is like similar record together and strictly separate the different records. As in the first group, you just mixed 50 yes and 50 no. That's why Gini is high. That it indicates that data is impure, and here all the 100 records are labeled with yes. There is no record labeled with no. That means data is pure, and so Gini value towards a 0, it's indicator increase the purity. Okay, and also another report is entropy, the same thing. You can use either one. Okay, and let's explain the important parameter. Just remember this. Just know this parameter. In the next session, I'll explain. I mean, you'll see how we can use those parameters to create the decision tree model. First is the max depth. Max depth is control the maximum depth of the tree. Small depth means simple tree. Large depth means complex tree. But too much large leads to the overfitting. So optimum value should be given for the max depth. Not too slow, not very high. And the mean sample speed. So minimum numbers of samples needed before splitting a node. Higher value makes the tree simpler and restrict it from the learning noisy pattern. Okay, and criteria. Yeah, actually, criteria means actually um, how the base split is selected. This is a Gini, fast and default or entropy. As I said before, this algorithm actually find a best split selection. You can say algorithm. Okay, and let's discuss the advantages and limitations. Advantage is like easy to understand and visualize, no feature scaling required, handles numeric and categorical data, captures nonlinear relationship, and fast prediction. This is the advantage of the decision tree. And limitation can easily overfit if allowed to grow too deep, sensitive to small changes in training data, less accurate than ensemble method, and hard to interpret if unrestricted. And also have a look evolution matrix, classifier evolution matrix. So the decentric classifier evolution matrix. What we actually consider is accuracy and precision. What is accuracy? Out of all prediction, how many are corrected good for balanced data? If your data set is balanced, your accuracy of precision will be good. And precision, when the predicted positive, how often it is right. Okay, very crucial. Like spam detection, loan defaulter. Okay. Recall and F1 score. Recall is out of actual positive, how many are found. It's also very important. And F1 score is a balance of precision and recall. Okay, so F1 is a combination of the precision and recall. And last one, the confusion matrix, a table actually directly comparing the actual and predicted values. So the true positive, false positive, true negative, and false negative matrix, so that you can decide how your model behaves. And then regress evolution matrix, decision tree regressor, that is MAE, mean accelerator on average. How much is the model prediction different from the actual numeric value? Lower is for good, is a for good model or better model. And MAC, RMAC, MAC squared the error, penalize the large mistakes heavily. And RMAC square root of MAC, converting the error back to the original one. That's all. So you can easily interpret the result. Actually, MAC means actually again I try to explain in short. Suppose there is a minor error. If we only use the RMAC, you cannot. You can think it. You can ignore it. But if you root square it or MAC, use the MAC, it will the value will be bigger, and it will highlight the error. Okay. And it's the R2 square. R square score, what is the coefficient of determination. It will how much variation in the target variable is captured by the model. Okay. So key takeaways is the decision tree is learned by asking sequence of question, yes or no question. Each split aims to make the resulting loop as pure as possible. It works for both classification and regression problems, and highly interpretable and great starting point for previous ML. And advanced like random forest both are built upon this core idea. So if you uh, have idea on decision trees, and you can easily understand the random forest both and that. Okay. Now I'll show you one image so that you can understand the data splitting part. Suppose there is actually initial mean like this. You can think like a basket of fruits where different type of fruits are present in the basket, right? Here, apple, banana, lemon, or orange, whatever. And you can see first is asking like question like technician is is it apple? If yes, all apple come the left side, and no, remaining fruits are in the right side bucket. Okay, so in the left side the apple basket is pure right now, but this left right side basket is impure because still mixed value or fruits are present, right? So again, it's asking question like, is a banana? Then at the left side, banana are separated, and right side remaining. But here you can see no mixed fruits are present. And only orange is left over there. So now your decision end. You don't need to take more question. So because all are pure right now. So like same process actually followed in a decision. So that's all for today. Uh, and in the next lecture, I'll explain. I'll show you how to create, build a decision tree model and use it. Thank you.